All right, so this is 5.3 in Calc 30, and the question says, for what values of the constants c and d is this point a point of inflection of the cubic curve y equals x cubed plus cx squared plus x plus d? So we've got two unknowns here. The points of inflection come where the second derivative is let equal to 0, and that's the x, and then you can solve for the y. So let's start by finding the second derivative here, and what we'll do is we'll keep, c as a constant and d as a constant. Now d is gonna be gone right away, right? Because when we take the first derivative, the derivative of a constant d is gone, so that's gonna have to come into play a little bit later. And this is gonna be 2cx plus 1, and then the y second double prime here is 6x plus 2c. Okay. All right. So if we let this equal 0, then we would be finding the x value that would sort of represent a point of inflection. So the x value is 4 in question. And so if I plug in 4 here, then I can find the c value that should make this rest of the statement true, I guess. So again, I would be finding 4 if I solve for x here. But because I'm given 4, I can now solve for the unknown c. So that's where I would go. Was there a hand up that I saw out of my periphery? No? Okay. So let's try that. So 6 times 4 plus 2c. So that would be negative 24 equals 2c, or c equals negative 12. Okay, so if c equals negative 12, then we know that 4, negative 7 is on the graph.
Wait, why would it be negative?
Because this is 24, and I put it over here to negative 24.
Oh.
Yeah. So, no question? Okay. So then, knowing that this is on the graph, this 4, negative 7, I got to find d as well. So d only exists in the original function. So if this was negative 7, this y, and if x was 4 here, 4 here, 4 here, and then c is negative 12, I should be able to solve for d. So I think that's what I'd like to try. Negative 7 in place of y here. And we'll go 4 cubed, which is what, 64? Plus negative 12 times 16, 4 squared, plus 4 plus d. So what have I got here? I got 68. What's 12? 12 times 16. I'm just gonna default to the calculator here today. And 16. So that's gonna be negative 192. We got 68 here. We got plus d. So we're going to subtract 68. Well, I guess we could combine these two. Negative 192 plus 68. Oh, I didn't catch my negative of the answer. Plus 68 is negative 124. So I'll add 124 to negative 7. So that one I can do. What's that, 17? So positive 117 is D. Looks like. Let's check that. Yeah, C equals negative 12, D equals 117. There's a solution there. Okay? So that's a tricky one. Yeah. Where do you start though? Well, you start by knowing that points of inflection come from second derivative. So if you don't know how to get the answer right at the beginning, just start with what you know. Second derivative is point of inflection. So go to the second derivative, then see if you can figure out what to do from there. Another question or?
I was just wondering how you figure out to use this -7 for the other one.
Well, if we go back to the, okay, so how do you know to use the -7? This point is already given, okay? So we're trying to find values of C and D that make this point a point of inflection. So we're going to assume this is a point on the graph and it's a point of inflection. So if I include 4 for x, then I have to include -7 in for y because I want to solve for this d.
Okay.
Yeah, so I just have to fill everything else in. Yeah.
Oh, yeah.
Okay?